2300 and Domini. People are haunted by the threat of war, not only within the human race, but also by the possible war of independence from aggressive extraterrestrial civilizations. To ensure the safety of mankind, we need armored ships of the regular space fleet. Let's review all types of space weapons that humanity can create in the foreseeable future. The best option for fast and mass production can be guns with powder charges. They can be placed on any type of ships, either 200 kg drone or super heavy battleship. The recoil of the guns will damp due to the output of powder gases through the nozzle behind the breech of the gun, according to the technology of recoilless guns. But this causes a drawback: the low speed of the shell. It makes sense to place guns with a high rate of firing on heavy ships, and to neutralize the impact due to the joint work of gyrodynes and engines. The disadvantages of such weapon is the limited speed on the shell, within 200 and 5000 meters per second, due to the characteristic of the chemical reactions, as well as the need to deliver both shells and cartridges to the fighting compartment. Powder shells belong to rocket shells, but most likely they will not find wide application due to the extremely low airspeed. An effective way to implement gunpowder can be the separation of the enemy by fire and the firing of heavy targets. The armor of medium and heavy ships will be able to cope with small caliber guns. Only evasion will help against large guns, cause one may fire using fragmentation shells with a radio fuse. The warhead will be torn as close as possible to the enemy. If the ship gets a hull-piercing through an armor-piercing shell, the crew and internal modules in the affected area are guaranteed to be destroyed. The difficulty of the implementation of the armor-piercing shells is that the shell must be turned off the target with a pointed side to penetrate the armor. And since there is no atmosphere in space, it cannot glide through the air to maintain the necessary orientation. Therefore, it will be necessary to embed gyrodyne inside each shell. Despite these shortcomings, powder tools are the cheapest to manufacture and one of the most simple to use. As a result, in the comparison table, the powder gets 5 points for cheapness and the ability to fire at any distance, 4 points for high power, 3 points for armor piercing and only 1 point for accuracy. More expressive in production are Gauss guns and railguns, an electromagnetic weapon. Gauss guns and railguns are more effective than powder guns due to the fact that shells can be accelerated to any speed. So it will be more difficult for the targets to evade the high-speed shell, which can also penetrate thicker armor and cause more kinetic damage. Theoretically, you can shoot from the railguns with any shell at all, whether it be fragmentation, stone or a bunch of flowers. Also we should mention the widely used today KEP, Kinetic Energy Penetrator, whose space analogous will be used against the most armored targets. Such space crowbars will be able to flash through any ships regardless of the presence of active protection and the quality of the combined armor, and an attempt to repel the shell with a laser will only increase the damage by turning the ingot into a plasma. Significant advantages over powder tools are the absence of sleeves, weaker recoil, higher ability and durability. A serious minus of all Gauss guns is a long time for charging capacitors, that is a low rate of fire. The rate of fire can be increased using superconductors, however this will entail additional expenses. And electromagnetic guns get 5 points for the ultimate penetrating ability and the same for an infinite range of fire, 4 points for ease of use and damage, 3 points for accuracy. The next step in the development of electromagnetic tools are plasma guns. They inflict damage by firing at the target with clouds of plasma. To obtain an effective plasma shoot, it is necessary to heat any substance to such a temperature at which it will turn into a gas state and will conduct current. To do this, it's necessary to heat the substance, for example iron, to a high temperature. In this case it will be close to 3000 degrees centigrade, and then to bomb the resulting gas with an electron flow for ionization. And finally, the red-hot ionized bolt will be directed to the enemy by the railgun. When hitting the ship with such a shell, a hole will be made with the intended heat stroke. In addition, the target will receive an electrical discharge, which can turn into a destructive force if there is an electronic nearby. The best will be active defense and combined armor like in a modern MBT. When plasma hits the ship, the hull remains almost intact and the crew and electronic are disabled. One of the ways to create a weaker, low-temperature plasma is launching a cumulative jet into the enemy. The cost of the shoot is very cheap, for which we have to pay with low fight speed, minimum range and weak damage, but such a jet will be able to puncture thick monolithic armor. Such guns will be advisable to provide a swarm of attacking drones for close combat. The biggest drawback of all plasma guns is the gradual decomposition and cooling of the bunch with time. Therefore, they cannot be effective over long distances. In addition, plasma weapons are very resource intensive, so it makes no sense to make them basic. Rather, it should be a trump card against strong targets. Plasma gets 5 points for destructive power, 4 points for penetration, 2 points for high cost, and 1 point for low range and bad accuracy. The next step in the development of weapons are lasers. Most likely, the thought of them immediately arises at the very first mention of cosmic battles, because it is known that today lasers are successfully tested on Earth. At first glance it seems that this is the most promising weapon, but even in a non-atmospheric space, their use is fraught with serious difficulties. In order that the laser may emit energy, it is necessary to pump it. Depending on the laser device and its pumping, the avalanche of the beam will have different properties. Laser weapons are powerful emitters of photons, carriers of electromagnetic radiation. First, you need to understand the types of lasers. В зависимости от устройства лазера. To date, about 35 species of them have been developed, and only 2 of them have prospects to become mass-produced weapons. These are chemical oxygen iodine lasers and the free electronic lasers. A free electronic lasers is a very weapon that most often appears in science fiction books, movies and games. It requires a powerful source of electricity and an appropriate cooling system. The beam of this laser is in the infrared range of waves, so it is invisible to human eyes. To get energy for firing, you need a powerful power station. Solar panels in space battles are the worst of energy sources, since they will not be able to generate enough energy in a short time to cause serious damage. In addition, they occupy a large area, have low strength, relatively weigh a lot, do not work at high and are ineffective away from the stars. It makes sense to use solar panels in conjunction with lasers unless it at civilian station as a basic missile defense. For military purposes, you need to use nuclear or thermonuclear reactors. The power of such lasers today reach nearly 100 kilowatts, which is enough to cut a sheet of metal at a peak power at close range for 5 seconds. In terms of the transmitted, such a laser is comparable to a Q from an AK-47 machine. The differences are that the laser damage is strongly dissipated at a distance and absorbed by the target, and the machine's bullets hit the point without a noticeable loss of energy. Of course, for offensive operations in space, you will need gigawatt capacities that may be available in the future. Do not forget that while sending 1 gigawatt of energy to the enemy, the device itself will receive a heating capacity of 4 gigawatts, which will require a powerful cooling system, so the protection of such a complex will be very expensive. The second type of combat laser is chemical oxygen iodine laser. Its efficiency is much higher relative to the previously mentioned laser. It is much cheaper to produce. It practically doesn't not overheat and is easy to maintain. Chemical lasers runs on chemical reaction and therefore do not require powerful power plants. Instead, they need to be charged with chemicals: chlorine, iodine, hydrogen and potassium hydroxide. For firing, the laser needs to simply warm up for 45 meters of work, make a series of shots, and then remove the byproducts of the reaction overboard. The beam of this laser is in the ultraviolet range and is also invisible to the human eye. Today, the power of the second damage of such lasers reaches about 1 megawatt, which is comparable to the power of the Soviet F-22 gun. Comparable if 150 such lasers and one cannon are fired at a shell without explosives. Of course, the lasers will not work for 1 second, but even if it works for 150 seconds continuously, it will not cause more damage than the gun, because it in turn will have time to make a whole series of shots. It is advisable to use lasers as an anti-missile defense of any ships, as one of the options as a secondary weapon of destroyers for pinpoint damage of enemy modules. It will also be justified to create a link of laser attack planes, focusing the beams of the lasers on a single target. We should mention that the farther the laser is from the target the focusing lens is needed, the degree of divergence of the beam depends on it. Since the battle in space will occur at distances of about 10 km, for causing damage you will need to take as large a lens as possible. If the lens is 10 cm in diameter, then at a distance of 10 km the beam will increase by 25 times. If the lens diameter is 1 meter, then at distance for 10 km the spot will increase only a little. It will be necessary to apply such energy to the area of this meter spot to make the armor melt. And these are huge numbers. Do not forget that the armor of the enemy in any case will be covered with a reflective coating. The body will have rational angles of acylation and may be covered with a sublimation resin, which absorbs heat into a gas that additionally prevents the passage of the beam. And finally, it is worth considering that fire will take place at dangerous targets, and if the target is dangerous, then it is mobile and will be able to turn off the overheated parts of the body from the laser. On this basis, it becomes clear that laser weapons in space do not have prospects to be the main primary weapon, since they require huge production costs, are physically vulnerable, have a limited range and are easily reflected. The result of lasers are as follows: 5 points for accuracy and 1 point for the rest. Moving gradually from lasers to the next type of weapon. It is from maintaining nuclear pumped lasers first. These are lasers that emit short wavelength X-rays. A powerful X-ray beam to a target leads to evaporation of the cladding material, the generation of shock waves in the material that destroys the integrity of the hull, as well as induced radioactivity. This is when the armor itself becomes a source of radiation. These lasers will be most effective as a missile defense system, as well as an offensive weapon when firing at enemy drones or satellites with weak anti-radiation protection. Radiation exposure causes burns and radiation sickness, which, depending on the severity, during few hours of weeks, the crew is incapacitated. The speed of the particles of a nuclear laser is equal to the speed of light, so the target cannot dodge the beam. The firing range is limited, which is the norm for all lasers. There are two ways to create a deadly beam: a powerful dispersible device directing a nuclear charge, or a weak reusable reactor with a guide outlet, but its power is hardly enough to damage even weakly protected targets. One powerful one-time device may not be enough to destroy protection targets, so for their effective destruction you will have to focus dozens of even hundreds of radiating rods. Besides the directed beam of radiation, there are nuclear and thermonuclear warheads. Both types of warheads carry radiation. They are effectively used as a fill-in of guided missiles, torpedoes or space mines. The explosion of a nuclear warhead produces light and radiation strikes. The intensity of penetrating gamma particles is twice as low as alpha and beta particles, and the total amount of radioactive radiation taken is 3 times weaker than the light impact. The rest of the kinetic and thermal energy will not play a significant role as a striking factor. The main drawback of nuclear and thermonuclear weapons is the difficulty of delivering the warhead to the enemy, because you can shoot down a nuclear missiles from almost any weapon, and especially effective with the help of missiles and lasers. One of the features is that an explosion of a nuclear charge will spread a directive dust in space. Another way to implement nuclear and thermonuclear weapons is to fill the charges of orbital mines, which when approaching an enemy station attract and work. The best way to release a nuclear charge is to use a ballistic shell launch from a railgun as a heavy target as a warhead. If such a shell penetrates the ship's armor, the enemy will be dealt a tremendous damage with guaranteed damage to equipment of any size. Evaluation of nuclear pumped lasers is as follows: 5 points for high accuracy, 4 points for significant damage, 3 points for a limited range, and 2 points each for cost and penetration. Evolution of nuclear and thermonuclear warheads is as follows: 5 points for an infinite range and destructive force, 3 for a cost and penetration ability, and 2 points for accuracy. Neutron bombs. These warheads are delivered to the enemy by the same methods as nuclear bombs and in many respects are similar in principle of operation. The differences are that neutron charges cause less damage to the equipment and more to the crew. These bombs produce 5 times more gamma particles and 10 times more neutron flux, which will make possible to break through the protection of even highly protected stations. The crew of the damaged ship will be forced to immediately leave the vehicle in order to have at least some chance of survival. The disadvantage is that in space battleless ships will most often be managed remotely from protected centers, so there will be no one on the front line who will be particularly amazed. 5 points for the ultimate penetration ability and the ability to send charges at any distance, 4 points for the strongest damage to the crew, and 2 points each for the cost and accuracy. A beam weapon is a type of weapon based on the formation of a beam of particles accelerated to near light speeds. The emitted particles can be electrons, protons, ions or neutral atoms. Of these particles, it is most effective to use neutral hydrogen atoms. A beam weapon has 3 types of damaging factor: mechanical impact, radiation and electromagnetic pulse. The effective fire range is limited to several hundred kilometers. The magnetic field and the atmosphere of the planet strongly disperse the density of the particle beam. Therefore, the weapon will be ineffective in low orbit. For the Earth, the effective height is over 250 kilometers. The mechanical effect of the cannon on the target will occupy a large area. So armor with sufficient density will not receive kinetic damage, but will only take a push. As a countermeasure to radiation and X-rays, armor with enhanced anti-radiation subwave will serve. Ion damage will be the strongest, but not the most penetrating factor. The flow of ions directed at the devices of the enemy will lead to short circuit followed by the destruction of the electronics and the nearby crew. Probably you would also like to learn about ion guns, which are the most famous type of beam weapon, but they most likely will not find wide application, since their effectiveness is lower than atomic guns. At its core, a beam weapon resembles incendiary aircraft shells. In places of the ship in which there is a hole or too weak armor, serious damage will be inflicted with possible ignition. As an offensive weapon, it will manifest itself in all its strengths when it completes its down targets or defeats poorly defended targets. These weapons will also be effective in countering missiles and ballistic weapons, powder tools, railguns. As a result, the beam weapon receives the following points: 5 points for maximum damage, 4 points for good accuracy, 2 points for high cost, and 1 point for weak penetration power and low range. The powder guns will occupy their niche as the main weapon in the initial stages of the construction of the space fleet. After a while, the railgun will come to replace them. As the protection of ship grows, the plasma guns will gradually force out the main mass of railguns, but not completely. The latter will be used against super armored targets. Lasers will occupy their specific niche at all stages of weapon development as light weapons as a way to counter missiles, bombs, torpedoes and mines. Nuclear and neutron warheads will be an integral part of the space arsenal, because they will be the stuffing of combat equipment. The beam weapon will complement the above types of piercing weapons with its damage. What extraterrestrial creatures make humanity have to fight within space? The question remains open, and if you are interested in, it may be the subject of a separate release. The video was voiced by Slavacel. Thank you for watching, and I wish you a peaceful community and friendly neighbor in the galaxy. Sorry for my English, and see you soon!